In this video, we are going to solve question 6.56. A truck of mass 10,212 kg moving at a speed of 27.4 meter per second has lost its brakes. Fortunately, the driver finds a runway lane, a gravel-covered incline that uses friction to stop a truck in such a situation. In this case, the incline makes an angle theta equals 40.15 degree with the horizontal. And the gravel has a coefficient of friction of 0.634 with the tires of the truck. How far along the incline delta x does the truck travel before it stops? So question has given me a truck which has a mass of 10,212 kilogram. And this truck is moving with a speed v, which I will call its initial speed v1. So let this be the position 1 of the truck, and at this position I will call its speed as v1. v1 is given to be 27.4 meter per second. Since the truck has lost its brakes, the driver is moving the truck along a gravel-covered incline to use the force of friction for stopping the truck. The angle theta of the incline is given as 40.15 degree, and the coefficient of friction between the tires of the truck and the incline is 0.634. Now when the truck climbs, now when the truck travels along the incline and comes to a stop, let this be the point where the truck comes to a stop. We will call this point as 2. Since it comes to a stop, its velocity at that point will be 0. Velocity at point 2, which we will call as v2, will be 0. Now there are non-conservative forces involved in this situation. So we are going to use the generalized form of work energy theorem to find the distance covered by the truck along the incline, to find what is delta x. When the truck is moving along the incline, the force of friction is doing a work to stop the truck. And work done by the friction force can be given by change in kinetic energy of the truck plus change in potential energy of the truck. This is one form of the generalized form of work energy theorem whenever non-conservative forces are involved. Now I can write my change in kinetic energy as final minus initial value. So since the final value here I'm taking as 2 and initial as 1, I will write K2 minus K1. And we do the same thing for potential, U2 minus U1. Now we need to find what are the values of this kinetic and potential energies. At position 1, at position 1, my truck is at ground level. So since my truck is not raised at a height above the ground, potential energy at this point will be 0. So U1 will be 0. Since the truck is moving, you will have a kinetic energy, and we can write that kinetic energy K1 as half mv squared. At the final position, since the truck has come to a stop, at this point the truck has come to a stop. So at the final position, my kinetic energy will be 0. The truck has come to a stop, my velocity is 0, and if velocity is 0, kinetic energy will also be 0. However, at this point, the truck is raised at a height h above the ground, so it will have a potential energy which we can write as mgh. Now let's substitute these in our equation. We write work done by the force of friction equals K2 is 0, K1 is half mv squared plus U2 is mgh, U1 is 0. Now work is defined as a product of force times displacement. And here the force that is doing the work is the force of friction. We know in case of friction, this force of friction always acts in direction opposite to my displacement. So if my truck were moving right, the force of friction will act left. And since the force and displacement are opposite in direction, work done by the force of friction is negative. So when I substitute for the work here, I have to take the work by the force of friction to be negative. So let's write the work as a product of force times the displacement. I will write negative force of friction times the displacement equals negative half mv squared plus mgh. I want to find what is delta x. I would have rearranged the term and calculated for delta x here if I knew what is the force of friction and what is the height h. Both of this information is not given to me, and I need to find them. So let's start with the height h. If I draw my incline here, roughly, you draw your incline. This is my angle theta, and this is the height h. This is delta x, according to the figure. I want to find h, which is opposite to my theta. And we know that for opposite side, we can use sine of the angle theta. Sine theta is equal to opposite side over the hypotenuse. So I can write this sine theta as h over delta x. And when we rearrange this term, I can write h as delta x times sine theta. So this is the value of h I can use in my equation. Once we know what is h, let's find what is the force of friction. To find the force of friction, we need to find what are the forces acting on my truck at this position 2. So we will draw the free body diagram of all the forces acting on the truck at position 2. So let's start with drawing these forces. The first force you have is the force due to gravity acting vertically downward. Let's draw that force acting vertically downward approximately. Then we have the normal force perpendicular to the surface. And we have the force of friction, which is acting opposite to the direction that the truck will move. So at this point, when the truck is not moving, the force of friction is acting along the positive x. Force due to gravity, I will split into its component. One component will go along the x-axis, which we call as mg sine theta. The other component go along the y-axis, which we call as mg cosine theta. Now, from the definition of friction, we know that the force of friction is mu k times the normal force. And if you look at the diagram here, normal force is equal to mg cosine theta. So I can write my force of friction equals mu k mg cosine theta. Now I have both the values I needed to substitute in my equation here. Let's substitute the value of h and the value of f to solve the problem. So I will put the values. F is coefficient of friction, mg cosine theta into delta x equals half mv squared plus mg. H is delta x sine theta. Now, if you want, you can use shift solve at this point to calculate what is delta x. And I'm going to rearrange this term to write in terms of delta x to get the final answer. So let's move all the terms with delta x together. I have delta x here. I will move mu k mg cosine theta to the left hand side. And I will move half mv squared to the right hand side. So minus half mv squared when I move it to the other side becomes half mv squared plus half mv squared equals mg delta x sine theta. This term over here was negative. When I move it to the other side, it will become positive. Mu k mg cosine theta into delta x. So we can cancel off m. Now we can take the common terms on the right hand side together. I have mg delta x here and I have mg delta x here. Let's bring them together. Let's bring those mg delta x together. Mg delta x. Here you are left with sine theta plus on the other side you are left with mu k cosine theta. M is present in both the terms here, so we can cancel off the m. And you get we can cancel off the m and you get v squared over 2 equals g delta x sine theta plus mu k cosine theta. I want to find what is delta x, so we will divide by g and this term over here. You can solve further. Delta x will be equal to v squared over 2g sine theta plus mu k cosine theta. Now let's substitute the value. V is 27.4 squared. 2 times G is 9.81. Sine of the angle theta, which is 40.15. So I'll put that value here. Plus UK, which is 0.634 into cosine 40.15. And when you solve this, you should get your delta x as 33.9 meter. So this is the distance along the incline the truck has to move in order to come to a stop. If you do not wish to rearrange the term, you can always use shift solve at this point in the equation.